Welcome back, chemists. Today we are going to be covering day 5 of our Unit 8 notes, predicting products of double replacement. So we've already learned what a double replacement reaction is, how to identify them, but today we are going to learn how to predict the products of that reaction. You can think of this reaction as a partner swap, because what is going to happen here is that our cations are going to switch spots. So again, just like with a single replacement, when your elements go to move, you are always going to make sure that a cation, a positively charged ion, is always going to go with an anion, a negatively charged ion. You're going to know that you have this type of reaction if you see two compounds as our reactants. So if you see two compounds to the left of the arrow on the reactant side, you need to be thinking double replacement reactions. And where double replacement reactions happen, one of two things is going to happen. So you will either have the reaction proceed, you will have a precipitation reaction. In other words, a precipitate will form. So a solid will be formed from two aqueous reactants. And just to remind you, solid can be represented by an S, a lowercase s in parentheses after your compound. Or you can have no reaction happen. So if you figure out that both of your products would end up being aqueous, then no reaction is going to happen. So a little bit similar to single replacement in that a reaction can happen or cannot happen. We are not going to be using the activity series for double replacement though. We are going to be using this thing called the solubility rules chart. So this is another one of those things that you can find on your classroom periodic table. It is right next to your activity series on page 3 of the periodic table. So I have a class copy right here. There's my activity series, and there is my solubility rules chart. So that is going to be great for you to reference on your quizzes and tests, because it's going to let you know what compounds are solid and what compounds are going to be aqueous in water. So before we talk more about this solubility rules chart, I do want to review states. I know we talked about these on the first day of our units when we were talking about symbols in our chemical equations, but I know it's been a little bit. So, like I said earlier, that lowercase s in the parentheses is going to be solid. This is what a precipitate will be represented by. If you have a precipitate in your reaction, it's going to have that solid symbol next to it. The other symbol that's going to be really important for double replacement reactions is aqueous. AQ means aqueous. And again, aqueous, in case you forgot, just means something is dissolved in water, H2O. So you're aqueous if you are dissolved in water. And then the other two state symbols that you will see are going to be lowercase g for gas and that cursive L for liquid. We like to write it with a cursive L so that way we don't mistake it for a 1. That is our symbol for liquid. The two most important ones that you're going to see with double replacement reactions are going to be that solid and that aqueous symbol. So we're going to keep these in mind as we look at our solubility rules chart. Over here, I see on my left side of my chart this phrase that says compounds containing these ions are soluble in water. So again, aqueous meaning we're soluble in water. So if we contain these compounds, we are soluble in water unless, and we have our exceptions over here. Before I talk more about that, I do want us to write group 1 next to alkali metals. In case we forgot, the alkali metals are group 1 in our periodic table here. So, all of these ions right here Since they have no exceptions listed over here, if they are partnered with another element in a compound, as long as you see that ion, that compound will be soluble in water. So if you see the alkali metals like sodium or lithium, you see ammonium, acetate, chlorate, nitrate. Anytime you see these in a compound, that compound, we are going to predict it to be soluble in water. If you see chlorine, bromine, and iodine, these halides here, or sulfate, you have to be a little bit more careful, because most of these compounds will be soluble in water. But if you see this compound, a compound with one of these paired with it, and it is paired with one of these exceptions, it will be insoluble. So, for example, if you see silver chloride, If you see silver chloride here, we are going to predict that this is going to be insoluble in water, because compounds that contain chlorine are soluble in water unless chlorine is partnered up with silver, mercury, or lead. So if I see silver, mercury, or lead with my chlorine, with my bromine, with my iodine, I need to make sure I include that solid state symbol because it's going to be insoluble in water. That's going to be different from something like sodium chloride, which includes an alkali metal, and as we know, if you have a group 1 metal in your compound, you are going to be soluble always. But let's look at one more example of a compound that is soluble in water that is partnered with chlorine, that maybe isn't necessarily also with a chlorine and a alkali metal. So say we have magnesium chloride. This is also going to be aqueous if it's in water, because chlorine is one of our ions that we are soluble in water for, as long as we are not partnered with silver, mercury, or lead. So over here I see that my chlorine is partnered with magnesium. Since magnesium is not one of my exceptions, we get to say that magnesium chloride is aqueous. So there are a couple examples of how we would use that solubility chart. We're going to get some more practice with this as we do examples down here. If you are given an ion, you see a compound with ions that are not on this chart, we are just going to assume that all of our other ionic compounds are insoluble. Okay, so we're going to go ahead and do this first example here so you can see how we apply this chart and how we determine if a reaction actually occurs. So I see in example 1, I have 2 compounds listed on the left side of my arrow with my reactants. So that tells me I need to be thinking double replacement reaction. And now I'm going to have to predict my products. So when I go to predict my products, one thing I like to do is write the ions above my compounds, because what's going to happen is in water, these compounds, they're going to be aqueous, they're going to dissolve, and so all of those ions are going to be floating around and potentially are going to create a precipitate. So I have this silver plus 1 that would be floating around if I dropped this silver nitrate into some water, if I had a solution of silver nitrate. My nitrate is going to have a charge of -1. And remember, if you need to go and look up your charges for your polyatomic ions, just go to the back of your periodic table. We have that handy-dandy chart, which will tell us that we have a charge of -1 for nitrate. So there's my 2 ions that make up that compound. My other compound is potassium chloride, and I know that potassium is going to have a +1 charge because it is in group 1, and my chlorine is in group 17, so it's going to have a -1 charge. So like I said earlier, double replacement is a partner swap. You can think of these compounds as swapping partners, swapping friends. So these cations are going to go switch. So my silver here is going to go pair up with chlorine, since +1 and -1 will cancel each other out. We know that we will just need 1 silver and 1 chlorine to make that product, that compound there. I don't know its state yet. We're going to figure that out in a second using this chart. But I want to go ahead and figure out my other product as well. So I have silver chloride, and now I know that my potassium is going to have to go and pair up with the nitrate. Again, I have potassium with a +1 charge and nitrate with a -1 charge, so they are going to just cancel each other out with 1 ion of each. So that is my potassium nitrate, and I now need to predict my states for these compounds. We just did an example up here where I showed you that silver chloride is going to be solid, a precipitate. Just to reiterate, to re-go over what I just talked about with this, I saw that I did have this chlorine, this chloride ion, involved in this compound. And when I went over and looked at my exceptions, I saw that if chlorine is paired with silver, it will be insoluble. So that is why I can go ahead and write that S next to silver chloride. I also have potassium nitrate. Nitrate up here is one of my ions that if it is in my compound, we know the compound will be soluble. So I'm going to go ahead and write aqueous there. Okay. So since I had this solid form, this solid precipitate form, let's go ahead and write that we did have a solid precipitate formed. We can say that the reaction happens. So this is a precipitation reaction. If you see a solid formed from 2 aqueous reactants, your double replacement reaction will proceed. So the last thing we need to do if we know we have a reaction is balance our equation. We got lucky here, actually, because we are already balanced. So there is 1 silver on both sides of the arrow, 1 nitrate, 1 potassium, and 1 chlorine on both sides of the arrow. So we are actually all done. This is a balanced equation, and we have written our reactants, our products, and our states. That's going to be very important. Please make sure you are including your states in a double replacement reaction. This is going to help you figure out if the reaction actually happens. So with that example done, you're probably thinking now, well, what happens if the reaction doesn't happen? So we're going to go ahead and look at example 2 because that is going to be a great example of this phenomenon. So right here, I have ammonium bromide and sodium chlorate. I'm going to, again, do my partner swap and figure out my products in order to figure out if the reaction will actually happen. So as I did with my first example, I'm going to write out all my ions, so that way I know how to write my final formula when my cations swap. I have ammonium with a +1 charge. My bromide ion will have a -1 charge. My sodium ion will have a +1 charge. And the chlorate ion has a -1 charge. Again, you can look at your polyatomic ions chart to figure that out. But those are all my ions that we're going to have floating around in our solution. We're going to have these 2 compounds dissolved in water, and those ions are going to be floating around. And now we're going to go and swap our cations. So I'm going to go and put ammonium with my chlorate. Again, my +1 and my -1 charge will cancel each other out. I just need one of each ion to give me a neutral compound. We will figure out its state in a second. And we're going to figure out our other product. My sodium here is going to now go pair up with my bromine. We have a +1 and a -1 charge again, so they will cancel each other out very nicely and leave us with this formula. Now we're going to go and predict what state these are going to be in if they're in water. So I see up here, if I have a compound containing ammonium, it will always be soluble. There's no exception. So we can go ahead and put aqueous here. Same thing for sodium. Sodium is a group 1 metal. They are always soluble. If you see sodium in your compound is soluble. So there is my aqueous for that compound. So we have both of our products aqueous. What that means is that no reaction will occur. If both products are aqueous, no reaction occurs. So what I'm going to do is I'm going to cross out these products, and I'm going to write NR for no reaction, because both products are aqueous. If you had to justify why a reaction does not occur in a double replacement reaction on a quiz or a test, please make sure you specify that no reaction will occur because both products are aqueous. So those examples were nice because we already had our formulas for our reactants written out. Sometimes you will be given a word equation though, and you will need to write out your reactants yourself. Again, I think it's a good idea to write the ions for each part of the compound above the name so you can keep track of what is what and what needs subscripts. So our first compound here is lithium acetate. I know that lithium is a group 1 element. It's going to have a +1 charge. Acetate is one of our polyatomic ions. If I see on my polyatomic ions chart, C2H3O2 with a -1 charge, that is acetate. C2H3O2 with a -1 charge, that is acetate. And then we have calcium chloride. Calcium has a +2 charge, and a chloride ion will have a -1 charge. So when I go to write out my reactants, I'm going to make sure I cancel out my charges. I just need 1 lithium and 1 acetate to create that compound. This compound will be in a solution. This will be a solution of lithium acetate reacting with a solution of calcium chloride. So I'm going to need 1 calcium and 2 chlorine. There's my solution of calcium chloride. Now what we're going to do is we're going to swap cations and see if we get a reaction based on the states of our products. So lithium is going to go partner up with chlorine. I'm going to get LiCl. And calcium is going to go partner up with acetate. So I'm going to get calcium, acetate right there. I'm going to put the state down here since I've run out of room. So we're going to go and look at our solubility rules again. Up here, lithium is a group 1 metal. Chlorine is also listed as something that is soluble unless it is paired with these 3. But since lithium is a group 1 metal, we know anything with lithium will always be soluble. So we can write aqueous for lithium chloride, and for calcium acetate, same thing. Anything with acetate, always soluble. So we're going to go ahead and put AQ for aqueous. So again, we have both products are aqueous. So I'm going to go ahead and cross those products out and write NR. No reaction happens. And our final example, we have one final word equation we will do before you can start your practice problems. So for example 4, we are going to do the same thing we did with our previous word problem. We're going to write our ions up top. There's my potassium ion, my sulfate ion, my barium ion, and my iodide ion. So, potassium sulfate, I will need 2 potassium to neutralize that 1 sulfate. There's my neutral compound. So I have my solution of potassium sulfate reacting with my solution of barium iodide. Again, you can see that the barium will be canceled out by 2 iodide ions. So there's my solution of potassium sulfate and my solution of barium iodide. Now we're going to see if these will react and make a precipitate or not. So potassium is going to pair up with the iodine now. And barium is going to go, barium will go pair up with the sulfate. So again, we're going to look at our solubility rules. I'm going to go take my periodic table out. Potassium is an alkali metal, a group 1 metal. There's no exception. It will be aqueous. Barium sulfate, however, I see that sulfate has a couple of exceptions. If I have a sulfate with a barium, we are insoluble. So we're going to write that solid. So we have formed this solid precipitate, this barium sulfate over here. So our reaction does happen. And since the reaction does happen, the last thing we need to do is check if we are balanced before we can be done with this equation. I see that we are not balanced. We have 2 potassium and 2 iodine over here, and only 1 on this side. So I'm going to go put a 2 in front of my potassium iodide, and that will balance my equation. So that is how you predict the products of a double replacement reaction and determine whether or not the reaction actually happens. Make sure you are writing your states when you are writing out your double replacement reaction. They're very important and will help you predict if the reaction happens.